This is 7.2 transformation rules, and these are all going to be isometries. So a couple of notations to jot down. A transformation maps a figure onto its image and is described by an arrow notation. Okay, so we're going to be using this arrow to write out rules. Prime notation, you heard me talk about that earlier in previous sections for this unit. Prime is used to identify the image points. So in the figure below, K prime is the image of K. So it is mapped on like this. So K maps on to K prime. And so here you can do the entire triangle. The entire triangle JKQ maps onto triangle J prime, K prime, Q prime. Okay, so like we had kind of mentioned before, there's a pre-image and an image. So this one is going to be our pre-image. And then all of these with the prime notation is our image, so our new one. All right, so the first one we're going to talk about is a translation. And this is an isometry that slides a figure along a straight line path, moving each point the same distance in the same direction. So in this first example, we have, is it a square? Yes, it is a square. So we have square A, B, C, D, and it maps onto A prime, B prime, C prime, D prime. And so here you can see it is sliding to the right and then down. And so you want to be in particular about how many it slides over. So in this case, it says it's sliding 9 units to the right and 3 units down. So what you're going to have to do is you're going to have to write a rule of this type of transformation or this translation. And so you're going to say XY maps onto, and then in this case here, since it's moving 9 to the right, we're going to add 9 to X and then subtract 3 from Y. And you can easily see that by a coordinate. So if you look at C, C is at -3, 2. So -3, 2. And C prime is at 1, 2, 3, 4, 5, 6, 6, -1. So it went from -3, 2 to 6, -1. And so you can clearly see -3 plus 9 gives us 6, and 2 minus 3 is that -1. So you're going to have to be able to write out rules like that. So let's practice that. So here it says, graph the image of triangle XYZ under the translation, and then they gave us the rule. So the rule is going to be X minus 8, Y plus 3. So that means we're going to go left 8 units and then up 3. So that's one way to look at that. So let me move this out of the way. All right, so sometimes it's easier to just count it out. And so we're going to go left 8, 1, 2, 3, 4, 7, 8, and then up 3, 1, 2, 3. So that's going to be X prime. And we're going to do the same for each one. 1, 2, 3, 4, 5, 6, 7, 8, 1, 2, 3. So that one's going to be Y prime. And it's probably easier for me to just count how big this side is. 1, 2, 3, 4, 5, 6. So I'm just going to go 6 to the right. 1, 2, 3, 4, 5, 6. And that's Z prime. And so there's our image. All right, let's see on this next example. So they give us a rule, or no, we need to write the rule, but they give us the translation that took place. And so again, you always want to identify your pre-image to your image. So this is our pre-image up here because these have the prime notation. So let's just count for the P. Looks like the P goes 1, 2 units left and drops down a 10. So 2 units to the left. So I'm going to minus 2 to the x. And how many does it go down? 1, 2, 3, 4, 8, 9, 10, 11. And when we go down, that's going to be minus 11. So this one, and you can always double check with the coordinates to double, just see, make sure it is done right. So P is at 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. So P is at negative 6, comma 6. And P prime is at, I believe, negative 8. 1, 2, 3, 4, 5. Negative 8, negative 5. And so if we minus 2, that takes us to negative 8. If we minus 11, that takes us to negative 5. So that works out. All right, let's go to the next type of transformation, and that's rotation. This is an isometry, which a figure is rotated X amount of degrees about a point onto its image. Most rotations are counterclockwise, okay? Now, of course, that doesn't mean it can't be clockwise. So in this one here, it says the figure shows a rotation of 90 degrees counterclockwise. So what you need to do in order to figure this out, and you need to realize that when you draw a segment, which I drew for you, this dotted line, I believe you should do that on your notes. Draw it to the origin and then to the new one. That is 90 degrees. And so A is at 1, 2, 3, 4, 5, 6. 1, 2, 3, 4. So A is at 6, comma 4. A prime is at negative 4, 6. So you need to ask yourself, how did those values change? Okay, so I'm going to reveal the rule to you, and you're going to see how that comes about. So notice the X and the Y switched, and the Y sign changed. It went from 4 to negative 4, and the 6 stayed the same sign, stayed positive. And so this is always going to be the rule for a 90-degree rotation. So let's try another one. It says graph the image of triangle ABC rotating about the origin 180 degrees. Write a rule for this transformation. So what you want to do is you want to draw that dotted line to the origin. Okay, so I'm going to use the same color. So from here to there. And so one thing to remember is that, remember, 180 degrees goes basically on a flat line. Okay, and so since we need to go the same amount, it goes down 4 over 6, I want to do that same rotation. Okay, I'm going to go down 4. 1, 2, 3, 4, 5, 6. Okay, so 1, 2, 3, 4. 3, 4, 5, 6. So right here, that's going to be my A prime. Okay, and then you can clearly see when you extend that, it's basically a straight line, which is a 180-degree rotation. So let's see what A prime is at. So remember, A is at 6, comma 4. A prime is at negative 6, negative 4. So how did the rule, or how did the numbers change? All they did was change the sign. So here's how your rule is going to look. XY maps onto negative X, comma, negative Y. So that's where A prime is going to be. B is at 4, negative 4. So we need to change that sign to negative 4, positive 4. 1, 2, 3, 4, 1, 2, 3, 4. So that's where B prime is going to be. And you can clearly see that's a flat line, which is 180-degree rotation. C is at 8, comma 1. So 8, comma 1. That means it's going to be at negative 8, negative 1. So there's C prime. And so here is the new triangle being rotated 180 degrees. All right, let's try one more rotation. This is 270 degrees. So remember, it's always going to go counterclockwise. So another way to think of this is that this is 90 degrees clockwise. So one thing that's easy to do is to do, you're going to go this way, but then you want to do that opposite reciprocal slope to create that 90-degree rotation. So remember, if it goes 6 over down 4, that means we're going to go down 6. 1, 2, 3, 4, 5, 6, 2, 3, 4. And so you can see how that's a perfect 90-degree rotation. Okay? 90-degree rotation to the right, but 270 degrees all the way around. So this is going to be my A prime. And so remember, A was at 6, 4. A prime is at 4, -6. So the numbers switch spots again, only this time the y changes sign. So this is going to be y, -x. Because this one, which was originally in the x spot, switched over here and the sign changed. So that's what our rule is going to look like for 270. And these are always going to be the rules for these three rotations. And we really won't do any other degree rotation. All right, so let's do the C. So C was at 8, 1. So we're going to switch them. So now it's going to be 1, -8. 1, 2, 3, 4, 5, 6, 7, 8. So that's going to be C prime. And then B is at 4, -4. So then now it's going to be -4, -4. 1, 2, 3, 4. 1, 2, 3, 4. And that's B prime. So here is the new triangle, the image of this one rotating 270 degrees counterclockwise. All right, let's go to the last type of transformation, reflection. This is going to be an isometry that flips a figure across a line, creating a mirror image of the figure. So here, this one's being reflected over here to this side. One thing to do is to just focus on how the values change, just like we did with rotation. 3, 1, 2, 3, 4. So C is at -3, 4. And C prime is at 3, 4. So all you notice is that the sign changed on the X. So you're going to see in the rule that it's simply just -x, y. So this is always going to be the rule for a reflection over the y-axis. Let's try a different type of reflection, a different type of transformation. So this one says reflect it over the x-axis. Okay, so the first thing that you want to do is you want to draw the line of reflection. Okay, so there it is. Let's make it red just so it stands out. So the easy way to think of this is draw how many units it is away from the line of reflection. So that's 2. So we're going to go 2 in the opposite direction. So that's x prime. The y is 3. So we're going to go 1, 2, 3 in the opposite direction. Same thing for the z. 1, 2, 3, z prime. So here's our new reflection image. That is being reflected over the x-axis. And so the rule you can see, well, if x was at 2, +2, and now x prime is at 2, -2, you can see the y changed. So this is what your rule looks like. Okay, so let's look at the last one. This one is going to say reflection over the line y equals x. So the reflection over line y equals x is something like this. Okay, and so again, all you want to do is count how many units it is away from the line of reflection. So R is 1, 2 diagonals away. So we're going to go 1, 2 diagonals over here. And so you're going to do the same for each one. Or really you can do it for 1 if you want to try to figure it out. So, or figure out the rules. So let's try Q. 1, 2, 3, 4.5 diagonals. Half, 1, 2, 3, 4. So that's where Q prime is. Y is 1, 2, 3, 4.5 again. Half, 1, 2, 3, 4. There's S prime. Oh, so you can see how it ends up being drawn out. Again. And this is 3 units, 1, 2, 3. So P prime is going to end up being right there. Okay, so a lot of people think it ends up being looking different, but this is the exact reflection over the line y equals x. So let's figure out a coordinate. R is kind of tough to work with because it's -2, +2, and it's always hard to tell what's happening when it comes over here. So let's try Q or S. S is at 1, 2, 3, 4, 5, 6, 7. -7, 2 is S. What is S prime at? 1, 1, 2, and then 1, 2, 3, 4, 5, 6, 7. So S prime is at 2, -7. So what happened here as these letters changed, or the coordinates changed? Looks like they just switched positions. Let's double check one more time with the Q. Q is at -3, 1, 2, 3, 4, 5, 6. So Q is at -3, 6. And let's see what Q prime is at. 6, -3. So did they switch positions again? Yes, they did. No signs changed. So the rule for flipping over the line y equals x is y comma x. You switch the two coordinates, x and y. And that is it for transformation rules. So you'll have to be able to come up with your own rules on the homework.